Hello everyone, welcome to all of you. As you know that 13 February GATE exam conducted 2020 and today I discuss the question that is a memory based and which type of question asked in GATE examination, and we select the thermodynamics subject, not all the subject, because we are study entropy chapter and so on. We cover the thermodynamics subject, so I selected this subject and I started first question which is asked in GATE 2022. I started from the easy question which is asked in first shift GATE 2020. In the first question you see here Clausius inequality is valid for. This is the question, and option A, any process, reversible process, any cycle, reversible cycle. I discuss in entropy chapter, you can read that cyclic integral of dq by t is less than or equal to, this is the equal to or 0. This is the cyclic symbol. This is the cyclic symbol. So this is valid only for the cycle. You can see here dq by t is equal to 0, cyclic integral. This is valid for reversible cycle. A reversible cycle, and if dq by t is less than 0, then this is the irreversible cycle. That means this is valid for reversible or irreversible. If dq by t cyclic integral is greater than 0, then we can say that that cycle is not possible. So here the option C is right. Any cycle Clausius inequality is valid for any cycle. This is the first question of thermodynamics which is asked you. This is very simple question. The second question is also very easy, and this is based on the work done for the closed system. Now what question asked? In a process, initial pressure of gas is 110 kPa and volume is 5 meter cube, and that is the initial pi is given 110 kPa, that is 110 kPa, and volume is also given V1 is 5 meter cube, and it follow the process PV के power 1.2 PV, that is this condition is follow for the compression. If gas is compressed to 2.5 meter cube, then find the work done. That means this is the graph of this process. This is PV graph. This is 1 and compress 1 to 2, that is this one volume is given 5 meter cube, and here volume is given, that is 2.5 meter cube, and this process is PV a power 1.2 is equal to constant. This lies follow this process, that is the polytropic process. For polytropic process we know that the work done for polytropic, that is P1 V1 minus P2 V2 upon n minus 1, and we know P1 V1 and find out P2 V2, that is n is given 1.2. How we find out P2 is here P1 V1 के power n is equal to P2 V2 के power n. Here put the value. P1 is given 110 into V1 also given 5 1.2. Here P2 is not given. P2 is find out P2, and V2 is given, that is 2.5 1.2. Now P2 is equal to 110 into 5 upon 2.5. Now calculate the P2 value. What is the value? Please calculate the, for calculating P2 we get 252.7136 kPa. Now we put the P2 value and V2 value, P1 V1 value in this formula. P1 is here given 110 into, that is V1 value 5 minus P2 we find out 252.7136 into V2 is already given 2.5 upon 1.2 minus 1. Calculate this by the calculator and we get the answer in minus, because work done on this system here, work done on the system, so we get the work done is the minus negative value. So do not confuse for this value. If here asked that work done on the gas, then you put positive value, but not mention that you put the value minus negative value. And that is the answer. Calculate this thing. 408.92. This is the value, kilojoule. This is the value. And this is also very simple question, but you learn this formula P1 V1 minus P2 V2 upon n minus 1 and follow by this concept and you get the answer. This is the third question which is asked in GATE-2022, and this is also a very simple question. It is based on the first law of thermodynamics, and now let's what question asked. Consider 1 kg of ideal gas at 1 bar and 300 Kelvin in rigid and perfectly insulated container. That means there is a container which is rigid. That means rigid volume is constant of container, and here ideal gas, that is initial pressure is given P1. Suppose that P1 is 1 bar, that means 100 kPa. This is the kPa in the form of kPa, and T1 is also given, that is T1 is 300 Kelvin, and perfectly insulated means there is no energy interaction within the container. That means no heat transfer from the surrounding and container, and this is insulated, perfectly insulated. And now a stirrer perform 225 kilojoule of work. Here a stirrer arrangement, that is stirrer, this is rotated, and the work provide to the gas, that means 225 kilojoule. This is the work. This is the work provide to the gas. That means the work on the system, it can be write in negative form, that is the negative, when sign convention followed. If work done on the system, we take negative, and if system done a work, then we take a positive value of this. And assume that the container do not participate in the thermodynamics interaction, then find the pressure. That means what is the pressure of the P2? P1 is given, T1 is given, and we have to find out P2. What is the value of P2? So we know that first law of thermodynamics. What is the first law of thermodynamics? First law of thermodynamics says that the dq is equal to del U plus W. This is the first law of thermodynamics. We know already. Here energy interaction, their heat transfer, this is insulated, then this value is 0. This is the 0. This is the 0, and W is given. W is given 225. That means 0. For ideal gas, change in internal energy is written as the mCV T2 minus T1, and W is given, that it is 225, means here negative value 225. Now here sorry, this is the kilojoule, 2 to 5 kilojoule. And the mass is also given, that is 1 kg. We put the value 1, CV value also given 750. This is the value given in the joule per kg Kelvin. We change the value in the kilojoule per kg Kelvin, that means 0.750. And T2 is not known. T2 minus T1 is given 300 Kelvin is equal to 2 to 5, and we calculate the T2 value get the value 600. Why we calculate the T2 value? We know that for ideal gas PV is equal to mRT. That means if we write PV upon T mR, this is the constant value, then we can write here PV by T is equal to constant. That means P1 V1 T1 is equal to P2 V2 T2. Here already says that the rigid container, that means V is already constant, so V1 and V2 get cancelled, and P1 we already known, and P2 is find out, T1 T2 already known. Putting the value of P1 is the P1 here 100 kPa, this is given 100 kPa, and T1 also given 300 is equal to P2 is nano, this is the find out pressure, and T2 is already given, already calculated 600. Now calculate this value. P2 is 200 kPa, and in the option there is the bar, then you can write 2 bar. This is also a very easy question. And now we move the next question. This question is asked in second shift in GATE examination, and this question is very conceptual, and this type of question also asked in previous GATE examination, but there is some modification, and in the last GATE examination asked there is a container, that is a insulated container, and here pipe and filling the air. This is insulated tank, but in this year the question ask that heat loss, that is not insulated tank, this is the heat loss. Only difference is that in this question heat loss from the tank, here you can see heat loss from the tank. Now let's read the question. A rigid tank of volume 8 meter cube, that means volume is given, that is V is 8 meter cube, is filled with air, and pipe is connected to it, and air inside the pipeline is at that means pressure, initial pressure is given, that is in pipeline, that is 600 kPa, and initial temperature when pipe is filling, that is also given Ti, that is 306 Kelvin, and the tank is also evacuated, the heat loss from the tank is, this loss is Q is 100 kilojoule. The final temperature in the tank, what is the final temperature of the tank? This problem is based on the unsteady state. You can see here when any tank, that means this is the tank, and suppose that any water or any other gases come in this. Suppose here water is coming, that means 5 liter water coming, and here in exit is only 2 liter. After some time you get that there is accumulation of the water, that means you can see here there is a mass is accumulated, that means after getting some time, that means the mass is dependent on the time, and here you can apply the mass conservation theorem, that means dm upon t is equal to that m, this is entry minus m out. This is applied for the conservation of mass. Similarly, you applied energy conservation dE upon dt. This is EI, that means energy in and energy out. These are the conservation of mass and conservation of energy in unsteady case, because with the during time we can see here change in mass and change in energy. So this problem is based on the unsteady problem, and such type of question asked also in previous GATE examination. So let's solve this question. Here question says that the pipeline, this is the pipeline and this is the tank. Pipeline has temperature, this is the filling of gas. What is this, gas or air? This is the air, this is air. Here temperature is given and pressure is also given. When this valve is opened, then this air coming in the tank. First of all, this is the evacuated. Initially it is evacuated, means there is no mass initially. That means m1, that is m1 is 0. And you can see here no mass exit, that means exit mass is also 0. But after some time a mass is accumulated, that means m2 is present, m2, that means this is the accumulation of mass. This is the initial mass of air, and this is after some time we get the mass of air is m2. And what is the change of mass? That means we applied energy conservation, mass conservation in unsteady problem, dm upon dt. This is the change in mass in and mass out. You can see here mi there is present, mi is present, this means mi, and no mass out, because this is tank is fixed mass, that means this is the 0, and dm upon dt is right mi. And now energy conservation for unsteady state. Here energy, we neglect the kinetic energy and potential energy, and we get the equation du upon dt is equal to mihi plus q minus mehe plus work done cv. You aware from the steady state SFI equation, but here question is asked the unsteady problem. So we write down du upon dt, and du is written because ke plus pe plus u. This is the kinetic energy, potential energy, and this is the change in energy, but we neglect the ke and p, so we write down du upon dt. This is the equation of energy conservation, and this is the mass conservation. We applied this theorem and we solved this problem. Now we can see here me, this is the me is 0 because no mass exit, and work done is also 0 because no work done. This is not going any work done. And q is present, here q is present, that means heat transfer to the system, that means this is the negative. When heat is added, then we take this value is positive. Then we can write du upon dt is equal to mihi minus q. This is the minus q because heat rejected to the system, heat loss from the tank 1000 kilojoule. Now we put mi value is the dm upon dt, du upon dt is equal to mi dm upon dt hi minus q. Now we change the value. This is the change in internal energy and this is the change in the mass. We can write also here this is the u2 minus u1 is equal to m2 minus m1, that is hi minus q value is given 1000. Now we can write also m2, this is the u2 minus m1 u1, this is the small u1 is equal to m2 h1 minus m1 hi, this is I minus 1000. We already known that the m1 is 0 because evacuated tank, this term is 0, this is 0, m1, that means this is 0. Which term is remaining? Now we rough this thing. m2 u2 is equal to m2 hi minus 1000. Now m2 and u2 for ideal gas or air, u2 is written as the u2 cv dt, that means m2 is written pv बराबर mrt. from this here m is equal to pv upon rt, that means we write here p2 v2 upon r t2 into cv t2, this is the cv dt, and equal to m2, this is also written p2 v2 upon r t2 hi is also written as a cpti minus 1000. Now putting the value, this t and t is cancelled out and r is known, p2 is known, v2 is known, and now p2 is given, p2 is the same value, this is the pi. When this valve is opened, then here pressure and here pressure is the same, that means the p2 is equal to pi, then this is the given 6 kPa and ti is also given, that means 6 Kelvin. Putting the value this and v2 is also given 8 meter cube. Now we write all the value p2, that means s, p2 is 6 kPa into v2 8 upon r 0.287 for the air, and cv is value given 0.718 is equal to p2 is here given 600 into v2 is the same 8 upon 0.287 into 0. Now here cp value is also given 1.005 and ti value is given 306 minus 1000. Now only one thing, that is the r2, sorry, this is remaining, and only one thing is unknown value, that means this is the t2. What is the t2? Calculate this and we get the value of t2. Calculating this thing, we getting the value of t2 395.3866 Kelvin. This is the answer. And final temperature you put 395.3866 Kelvin. This is the answer. And only that thing is the difference in the previous question. This is the here given Q, heat loss, but in the previous year GATE examination asked that means here insulated given, then we will learn the formula, that is T2 is equal to gamma into Ti. we learn this formula and applied for the what is the final temperature of air when filling the tank. But here not use this formula because here given heat loss from the tank. Okay, this question is also asked in second shift. This is also very good question and a very conceptual question. There are two concepts are utilized in the same question, and how to solve this question, let's see. Steam turbine of steady state 500 kilojoule per second, steam enter with enthalpy of 3500 kilojoule per kg. There is the steam turbine, that is a steam turbine. This is a steam turbine, and there is a steam turbine, and here steam turbine is considered as the open system. That means here we make a control volume. This is the control volume, and this is the control surface. This is steam turbine. Now here entry condition are given, that is here steam is enter, that means here condition is the m is given, this is the 500 kg per second, and also enthalpy of steam at the entry is given, that is 3500 kilojoule per kg. This is the H1 value, and also given entropy in the entry, entropy that is S1 is also given here 6.5 kilojoule per kg Kelvin. In the question says that there is a steam turbine, entry condition is given and exit condition is also given, but here steam is not insulated, steam turbine is not insulated, some heat is rejected, that is heat, this is heat is rejected, but this heat transfer is reversible heat transfer. That means this is a particular temperature, that is a Q. Here temperature is given, and this temperature is given here reversible at 500 temperature is given at 500. That means this steam turbine heat is rejected to the temperature of 500 Kelvin in a reversible manner. And how this is, and also says that this is a steady state. Steady state means the mass enter is same mass m on 500 kilojoule kg per second, then the exit is also 500 kg per second. Now what is asked, this is asked, this is turbine, then what is the work, Wt is what. Now we applied the SFA equation, you know SFA equation, that is SFE equation, steady flow energy equation, because this is the steady state here given. And now we apply H1 plus this is a heat supply is equal to H2 plus WCV. This is the steady flow energy equation. Here all other energy is neglected, that is KE and PE is negligible. Here this is SFA equation. Now what is asked here, Wt is asked in the question, H1 is given, H2 is given, but we have only one equation. How to solve this question? There is two unknown, that is W and Q. Both are not known, but here Q is known, that temperature 500 Kelvin. At 500 Kelvin heat transfer is reversibly. How to solve this question? There is a concept behind it. We applied the entropy conservation of theorem. In this entropy conservation, we know that entropy conservation theorem. This say that entropy any system, entropy in, entropy out, in out, some entropy is generated, then what is the change ds with respect to time. This is the generalized form. We can write here ds upon dt. This is the control volume is equal to ds s generation plus mi minus, this is the si s out, entropy in, entropy out, s gen and plus q upon t. This is the conservation of entropy. ds upon dt, this is the unsteady state. When unsteady state, then ds is changes with respect to time, and s generation is also a phenomena in steady state. Unsteady state, yes I and s out, yes out, and q by t is here. This is the equation for the conservation of entropy. Now we applied this theorem and we get here in the problem say that the steady state, that means this term is equal to 0. S gen is 0 because of a steady state. Steady state means in and out is are same. Then s I in and s out plus q by t. This is right here s I minus s out plus q by t, this is equal to 0. Now we put s1, this is the one condition and two condition, and this is the q. Here q is not given but temperature is given. Now we put that is m s1 minus m s2 plus q. Q is a heat rejected, so we can write minus negative because heat is rejected from the turbine. So here negative term q upon t, t is given 500 is equal to 0. Now we q upon 500 is equal to m s1 minus s2. Here m is given, that means 500 into s1 minus s2. S1 is also given 6.5 minus s2 is given here, yes, 6.3. Now q is here, find out 500 into 6.5, here is 0.2 into 500. Now calculate this thing. Now we get 50,000 kilojoule. This is the heat. Now we calculate the 50,000 kilojoule and put this value in this term, and putting this value h1, m is also given, m h1 plus q plus here we write here this is negative because h1, this is h1 m h1 plus q h2 plus wcv m2h. This is the q is here, find out 15,000, m1 is given, m1 and m2 is same 500, h1 is given, what is the value of 35 minus h2 is also given, here h2 is also given 25, here 25 25 kilojoule per kg, and S2 is also given 6.3 kilojoule per kg Kelvin. Now we put the value 2500, and Q is a negative value because 550, negative because heat is transferred to the system, is equal to WCV. Now we calculate this and we get W 45000 kilowatt. Now this is convert into megawatt, 450 megawatt. This is the answer. I think this is a very lengthy question, and this type of question is never asked in previous GATE examinations, so the difficulty level of this question is more and more. These questions are memory based, so the numerical data may be different, but the concept behind it is the same. And this year GATE examination was more difficult. I think all of students are saying that GATE examination is more difficult in the previous examination. Something is a reason behind it, but we discuss more and more question which is asked in GATE examination to 2022, and now in the next upcoming lecture we continue the entropy chapter, and also we discuss entropy in this formula, entropy generation, and how to apply the entropy conservation. And okay, thank you.